Okay, let's start talking about the rest of Division 6A so we can finish this up. So if you remember, scope of work, we've completed the first part. We've completed the front porch framing now, and we are now moving on to page 2, which is wall framing. All right, so this is the part that's going to take the longest on this division. Just be patient, we'll get through it together. The nice thing is you were already assigned the third page to this, which included going through, finding, and calculating all your walls. So let's recap for a moment. What I had you do on your first floor plan involved coloring. You were told to color code both your exterior and your interior walls. Now, if you remember, I told you a couple things. Choose 2 different colors for your exterior walls, so you could do your horizontals and then your verticals. And then you could also do 2 colors on your interior walls, again, horizontals and verticals, focusing on that category, or as a naming category, as a naming option. So the labeling process included on the exterior walls, I used an EW1 for exterior wall 1, which I have up here. And then I followed the same suit, the same way I did on my footings, and I went around clockwise, so EW1, EW2, EW3, and EW4. On my interior walls, I used H and V for horizontal and vertical, and I just labeled them 1, 2, 3, 4, 5 with an H or a V in front of them. Here, for example, I have a H1 and H2 and H3 and H4. Same thing for the verticals. But I did tell you that you could use whatever system you wanted to. If you wanted to use A, B, C, D, or just straight 1, 2, 3, 4, 5, that is fine. Whatever process makes sense to you is fine with me, as long as it's organized and it's categorized. What you needed to do when you colored, if you remembered, I don't know if you can see it, but to pay attention on your corners, making sure, I think you can see it, that your corners don't overlap, because we need to get the accurate lengths of our walls together so that we can get an accurate length for calculating of bottom plates and studs and top plates. Okay? You were also to take the length of these walls and you were to apply them onto this sheet of paper. I gave you a spot for the label you gave them, such as EW1, EW2, H1, V1. I gave you a spot for color code so that it would relate back to your plans and you could find the wall in the future. And then I gave you a spot to write the length from the floor plan that you calculated, or either that the dimensions provided, and then of course converting it into decimal feet so you wouldn't forget to do that. Now, the first item on the scope of work for wall framing that it wants you to calculate is your bottom plate 2x4. And if you remember, I think I gave you an addendum that all the walls now on the floor plan are going to be 2x4 stud walls, not the 2x6 stud wall that was originally designed for the wall between the 2 bathrooms. So that will make things flow a little bit faster for us and a little bit easier in our calculations. Now, on this, if you would like to go ahead and use the space here at the bottom of both of these categories and go ahead and add up your lengths, so you would have a total length of your exterior walls and a total length of all your interior walls, that would be a smart thing to do, because then you could just transfer that information onto your audit trail and make sure you reference it back to this sheet so you're covered. The other thing that makes that really valuable is because in the future, especially the number for the total length of those exterior walls, we're going to need that information, because there are things we're going to apply to the exterior walls that are not going to get applied to the interior walls, and we're going to need that linear feet. Okay? All right, so that's bottom plate. Add it all up, add it together for exterior and interior, and you have your 2x4 total linear feet of bottom plate calculated. The next item, studs. Now this part's going to take the longest, okay? So just be patient. You will need to do this per wall. You cannot take the total linear feet and divide it out and get the total number of studs, because you will be short. Because each wall has a starting stud and an ending stud, and we have to accommodate for those. So your process is this. You will take the length of your wall individually, whatever you calculated it to be, say 20 feet, 20.00 linear feet. You will divide that by 1.33. Okay, that is your on-center spacing. You will divide that by 1.33. Whatever number you get will probably be in a decimal form, unless you're lucky. You'll have to round that up to the nearest whole number, and then for every wall, you will have to add 1, because we also need to get the ending stud for that wall. Okay? So that is going to give you the number of studs per every wall that you need. You will add those up, and that will give you your stud calculations. At least it will give you a start of your stud calculations. Okay? The next step is that for the stud calculations, we also have to add in our corners. Okay? Now, every corner on the exterior is a 3-stud corner. Well, the nice thing is, if we've already calculated for the beginning stud and the ending stud, then for every exterior corner, we only have to add 1 more stud. Well, in our house, we only have 4 exterior corners, so you're going to add 4 studs for your corners. All right? What happens after that is we need to look at the studs for the corners on the interior walls. Okay? So to calculate that, you will need on your set of plans to go through and find all of your corners. There's a corner, there's a corner, there's a corner, there's a corner, there, and so forth and so on, and find how many corners you have on the inside. All right, so let's draw some pictures here real quick. Your exterior corners, I told you, were going to be a 3-stud corner. Okay, so very simply put, we will have a stud at the end of each one of the walls. You can see this. So there's my stud at the end of this wall. That's my stud at the end of this wall. This is the additional stud you are adding per corner. Okay, the reason for this is, one, I've got to get insulation back behind here, and I've got to have a nailing surface here and here for sheetrock on the inside. I've also got to have a nailing surface here and here for your OSB on the outside. Okay, makes sense? All right. The more studs I put in a corner, the greater the chance I have for heat loss and heat gain, because while wood does have thermal insulating properties, it doesn't have as much as insulation does, or R value for our walls. Okay? Now, those interior corner studs. The nice thing is, I don't have to worry about insulation. Great. The only thing I have to worry about is having a corner for the sheetrock to nail into. So I need to make sure that all my corners are taken care of. So again, I still have my same 2 studs on the end. Well, this time, what I can do is just come in and place another stud to accommodate that, and I'll show you in just a second. And then I'll add blocking so I don't use a whole full stud. So see, again, still, I have my end stud just like I had up here, and I have my end stud just like I have up here. Well, this stud right here is going to happen because I need to have nailing surface here, but it's this section right here that they'll infill with blocking, because there's no reason to waste a whole nother stud, and I can use spare pieces that I have lying around to fill that in. I can save money on materials, and I'm not using a whole nother stud.